on Wednesday, we're gonna be meeting in the library. So don't come here, just come over to the, meet in the main area over there in the library. We're gonna be working on the computers in, what's that called?
The computer lab?
Okay, computer lab. That's where we're gonna be, and, Tony's gonna be giving a talk about using library resources. And I would strongly encourage you to be there. And if you know somebody who's not in class today, thank you for showing up, Isaiah, or just making an important announcement. They can tell you what it is. I'll wait so I don't want to repeat it. Related to that, your tentative research topic is due, according to the syllabus, on Wednesday. Because I'm such a nice guy, I'm going to delay that 1 week. But that's it, just 1 week. Partly because we're getting a late start on the talk over at the library, but yet I really, in all honesty, I told you before that shouldn't be slowing you down for coming up with the tentative research topic. Do I need a detailed account of exactly what you're going to be doing? No, I don't. What do I need based on what I've told you before?
Just a general idea?
Hmm?
A general idea?
Yeah, just a general idea of what you plan your proposal to address.
Do you want the operational definition and everything?
That would be nice, but at this point, I'm not going to require that. In fact, when we get to the second date, by then, I definitely want those kinds of specifics, but it certainly wouldn't hurt to at least take a stab at operationally defining what you're talking about. But some of you, my guess is, even with an additional week, you're still going to be sitting there thinking, can I put this off a little bit longer? I got better things to do, like take a nap or something equally important. I just need a general idea. I need to know. You got to be able to convince me you put some thought into it. That's what I'm looking for. And really, this is, as I've said before, this is more for your benefit than it is for mine. I don't need additional crap to look at and grade. I'm trying to keep you on track so you don't end up putting this off to the last minute. It's not a major part of the project, but it is worth 10 points out of 150. And every point you can get, I'm sure you want. Kathy, have you come up with an idea at all yet?
Yeah.
Good. I'm not going to put you on the spot and ask you what it is.
You already did. Yeah.
You already did?
Yeah.
Okay. I won't put you on the spot again. I can't remember who I've asked that and who I haven't. In fact, a few of you have already come to talk to me outside of class about that, and that's a good thing. I think I said earlier in the semester that this is probably a class where you may need to come talk to me several times outside of class. Just to let me know where you're at, give me an idea of what problems you're having or what questions you may have. I'll just sit there and nod and grin and say, you're on your own. Right, Alicia? No? Where's the pen? No, it would be a good idea to bounce your ideas off my head and see at some point. I just can't really imagine anybody not doing that at least a time or two during the semester. Okay, the other thing we need to address is your first test. Is it scheduled to be over the first 3 chapters? And if I'm not mistaken, we're in chapter 3, we're on reliability of measurement. And I'm not, we may be able to complete this chapter today. And then rather run the risk of waiting till the end of class to say anything more about it, I'm gonna say something now while it's on my mind. And we're talking about scheduling a test. For now, let's schedule it tentatively for a week from today. Because we won't be talking about it on Wednesday. We're gonna be doing something else, right? So if we get this completed, this chapter completed today, we'll have the test a week from today. If not, we'll have it a week from Wednesday. So let's see if we can get it covered.
That's the 16th.
What's today, the night? I guess it would be the 16th. I don't worry too much about the numbers. If I say a week from today, I know a week from today would be next Monday. At least that's the way I calculated. Am I right, Kinsley? So for those of you who need a date, the 16th. The usual time and place. Bring a green Scantron. Bring a pencil. Sharpened, if it's that type of pencil. Bring a brain, sharpened, if it's that type of brain. If you forget a brain, it's okay. I've got extras in my office in my brain collection. You would not believe I have a brain collection?
I don't know.
Huh?
I don't know.
That's a pretty impressive collection.
I can see you have a brain collection.
And I do. If you want to, after class, just walk up to my door. It's all sitting there on a shelf. I've got a glow-in-the-dark brain. I've got an eraser brain. I've got stress brains. I've got brain coral. I've got a candle brain. I've got, what else do I have? I got some kind of gross, sticky, gooey kind of brain. It's not real. I got all kinds of brains.
You got the brain of some kid at WT in there.
More than one. They weren't using it, so I just tell myself. Okay, so those are the announcements. Everybody straight on scheduling of things. Okay, let's talk about reliability and measurement. And just a reminder before I do, be familiar with the different types of validity we talked about. In general, what validity refers to, but we talked about several different types of validity. Be able to recognize examples of the different types, be able to give an example of the different types. Be able to discuss on 4 pages validity in the different types. Four pages is more than I want, but don't be surprised. I mean, that topic can be addressed multiple choice, short answer discussion, or all of the above. Or A and B, or B and C. And those types of questions that some of you hate. Okay, what does it mean, if I say a measurement is reliable, what does that mean?
You can use it to get similar results repeatedly.
You would get similar results, consistent results, when making the measurement. If I measure a particular variable on a group of individuals and I measure it again at a second point in time, and I get results similar the second time that I did the first time, and I do it a third every time, if the results are consistent, then I've got a reliable measure. One way to think of reliability is just think of it as consistency. Now, one of the assumptions underlying the concept of reliability is the idea that the variable you're measuring is relatively stable or constant across time. But we also know that anytime we measure a variable, that measurement is most likely going to contain some degree of error. In fact, I'm going to point out a simple formula to you on page 85. It just says measured score equals true score plus error. The measurement is equal to the actual honest-to-God score plus any error that is part of the measurement procedure. And one of the examples they use is intelligence. And with intelligence, there would be a score that would accurately reflect, at least to the extent that we can accurately measure intelligence, that would accurately reflect your degree of intelligence, but also we know that that score could be influenced by other variables. How well you do on an intelligence test might be affected by your current mood state. Like if you're depressed. How well you score on an intelligence test might be affected by how you happen to feel that day physically. Might be influenced by a number of other things. If it's a test where you're not penalized for guessing an answer, you may, for some reason, that particular day, hit most of your guesses correctly. It's far from a perfect measure. But the assumption is that we can take those two factors together to get our measured score, and that measured score, if we have a reliable measure, is going to be consistent across time. And the error component is going to average out to be effectively around 0. One of the things you want to do, if at all possible, is reduce that error component to the extent that you can. And you're not going to be able to influence the others, the actual measure of intelligence that much. If I test you one day and get a score of 104, and I test you another day and get a score of 170, how much of that is due to a change in your intelligence? Yeah, very little. If I got that big a difference, it would have to be due to unreliability of the instrument and or error component in my measurement. So it's a matter of, in order to get reliability, you've got to minimize the error component. And on page 86, it identifies some common sources of error. One is observer error. Uses an example of 4 people timing a 100-meter dash. Which reminds me, Caleb doesn't believe I can pump 400 pounds in a bench bench press repeatedly. He probably won't believe this statement either. I can run 100 meters in 9.9 seconds. You don't believe that?
I said, yeah, I believe it.
I saw that, I heard that.
I said, yeah,
You do believe it?
yeah.
Not today, maybe in your prom. Unless you consider your prom.
I probably lied a little bit. Maybe 10.1. You'll buy that? You just don't think I broke the 10-second barrier yet?
Maybe like 13.
No, shake my hand, I'd probably stop about midway for a snack and a smoke. I'd probably just stroll that 100 meters or amble.
A little stick up with a cigarette on a string in front of you.
Forget it, I already have them in my pocket. Okay, but observe, if you've got 4 people using stopwatches, you think you're gonna get exactly the same measurement from those 4 people? Of course, these days, if they're really wanting to get a precise measurement, they have it, timers that are they can calibrate that give you much more accurate measurements, don't they? I would assume. Okay. So you've got potential for error from the observers. You got potential error, it says, from environmental changes. In other words, things that are happening, when you test someone to determine reliability, you would like to have the conditions pretty much the same every time that the measurement is made. If you're bringing people into the laboratory to measure some aspect of their behavior, probably a good idea to measure their behavior under the same laboratory conditions. Participant changes. The fact that the person that you're measuring can change from one time to another. Individual differences, things that are part of the error measurement. And some degree of error is inevitable, or in most cases it's inevitable. But the less error you have, the greater the reliability. Okay. Let's look at some topics that fall under the heading of types and measures of reliability. One is, as Ty already pointed out, where you're measuring something multiple times. It's commonly called test-retest reliability. Measure a group of people at one point in time, measure them at a second point in time, and compare the scores to see if they indicate consistency from one time to the next. Now, here's one of those situations where I'm going to reintroduce statistics into the experiment. If I were going, let's say I administered a test to this group today. I come back and administer the same test to this group next week. And then I want to calculate an index of reliability. What statistic that we talked about in that class would be an appropriate statistic? In fact, I discussed this when we were talking about this particular statistic.
Z-scores.
Huh? Z-score? there's one that's be quite a bit better. And in fact, in practice, it's used very frequently to calculate test-retest reliability. Pearson R correlation coefficient. And for those of you who took my class, do you remember, you may not, well, let me just say this. When I was talking about this in that class, and we were talking about correlation coefficients, we were talking about ways, indexes that you can use to identify the strength of a correlation. And we were using some guidelines established by, I'm certainly not going to ask you this guy's name because I'm sure I would be shocked if anybody remembered the guy's name. Developed by Jacob Cohen to identify a strong, weak, or medium correlation coefficient. But they were lower than what I said would be required for test-retest reliability. In fact, when it comes to test-retest reliability, what's the minimum correlation coefficient that you would like to see? I would say 0.9, but in the literature, you'll find sometimes that 0.8 is considered acceptable. And we're talking a positive 0.8. But I would say 0.9 would be better. If you're planning on using some type of psychological test in your proposal, I don't know if I specifically said this, but one of the things you're going to need to do is find some information that on the reliability and validity of that test. You've got to be able to justify that the test you're using is reliable and valid. And one of the things you would want to know about the test is its test-retest reliability. So now some of you are thinking, crap, I was going to use a psychological test, now he's expecting me to go out and find out about the psychometric properties of that test. That's how it's done in the real world. You don't just grab some old test off the shelf just because it says something, so-and-so's intelligence test. You just grab that one and use it. And you need to find one that has reasonable reliability and validity. Anyway, that's a classic example of successive measurements. Another one that they got into the same general heading is, let's suppose that I have you fill out a test today. Then I give you another test on next Monday that is a similar kind of test. It's not the exact same test, but it's quite similar. If both tests are measuring the same thing, then I should see consistency of the scores, even though I'm using two different tests. And again, a good way to determine that would be to use a correlation coefficient. Okay, another type of reliability they talk about is simultaneous measurements. Talking about it's common to use two or more separate observers who simultaneously record measurements. And that's frequently done. Sometimes you have more than one person obtaining the measurements on your participants. But if you're going to do that, an important consideration is inter-rater reliability. are your observers measuring the same thing in the same way? And are they recording it the same way? In fact, in those of you who are in behavior modification, we just talked about this in the first unit of that class. You just answered some questions on the test this morning concerning this kind of a situation in our observer reliability. Back on part one, that little figure or table I had with the X's in it, you had to calculate in our observer reliability. How many of you think you got that right that are in that class?
I don't know, but it was part two.
Yeah,
It's part-
what did I say, part one? Part two, sorry. I didn't really get a start on grading, much of a start on grading part two, but the two or three I did say, city, didn't get it right. Even though it's a pretty straightforward calculation. Okay, another type of reliability has to do with internal consistency. In other words, the test that you're using needs to be composed of items that are consistent with each other. And one way of determining whether or not a measurement has internal consistency, one example they give is to use something called split half reliability. What's split half reliability?
You get half to one group, half to the other, and compare how well.
No, it's not half to one group, half the other, but rather you split the test into two parts, and then you calculate scores on each of the two halves, and then you compare those scores to each other to see if they're consistent with each other. So you get a separate score for each half of the test. You might have the first half compared to the second half. Or you might have a situation, you can do it different ways. You may have even numbered items compared to odd numbered items. And it gives a couple of examples of statistics you could calculate, but we're not going to go into those. But for those of you who just want to know the taste of statistics and something we didn't cover, it mentions Cronbach's alpha and the Cooter-Richardson formula. You can go look those up yourself later, so I know some of you will be anxious to do that, because you want to find out more about statistical measures, right, Ty?
Definitely.
But when you're looking, if you're considering using a test, and you're looking up information on validity and reliability, you may come across those terms and some of the other things we've talked about. And on the ones that that you calculate a correlation coefficient, I'm like Ty, I would prefer 0.9 or stronger. Okay. Reliability and validity, the relationship between the two. Let's just look at that briefly. And there are just a few statements in there I'm going to bring directly to your attention. One of those is in the very first paragraph. Reliability is a prerequisite for validity. That is, a measurement procedure cannot be valid unless it is reliable. You've got to be able to have consistent results for the measurement, or you don't have a valid measurement. There example is intelligence. I measure it twice, one time it's 75, the other time it's 160. One, that's not reliable, and therefore it's not valid. You could not have that big a difference if you're actually measuring intelligence. But then on the next paragraph, it says, on the other hand, it is not necessary for a measurement to be valid for it to be reliable. Now, isn't that kind of interesting? The example they use is, we can measure your height and claim that it is a measure of intelligence. And if we measured your height more than once, we would get the same measure. So we're very close. So it's reliable, isn't it? But it isn't valid. Yeah, it's not valid. That'd be kind of interesting. Take the group of people, measure how tall they are, and then administer a legitimate intelligence test, and then calculate the correlation between the two. Anybody want to speculate? And I have no idea what that might be, but I have a general ballpark idea of where it might be. You think you'd end up with a strong correlation, a positive correlation, a negative correlation, or zero correlation, or what? I don't think you'd have a correlation. I think you'd be pretty close to zero. Okay, so you have to have reliability in order to have validity. But you don't have to have validity to be reliable. Okay. Something else that's there I want to point out. Next paragraph. In situations in which there is an established standard for measurement units, it's possible to define the accuracy of a measurement process. For example, we know we have standards that allow us to measure precisely an inch, a pound, a mile, or a second. Okay. Now, occasionally, though, you may encounter an instrument that produces results that are consistently wrong by a constant amount. Let's say you have a set of scales at home that you weigh yourself on a daily basis. And every day you weigh yourself, your actual weight is 5 pounds different than what the scales tell you it is. In other words, there's always a constant 5-pound error there. Or is that measurement reliable?
Reliable, it's just not
Reliable,
accurate.
it's always 5 pounds over, but it's consistent. Is it valid? Is it? It's measuring weight, and if you weighed different people on it, it would be measuring weight for each of those people. And the fact that it is a constant error really doesn't raise much of a problem. But that's only if it's constant error. If the error component is variable, if it changes over time, then we got a problem. And we shouldn't be using the instrument. preferably, you don't have that constant error. All I'm trying to point out is constant or consistent errors are not as big a problem as inconsistent errors. Okay, next topic, scales of measurement. You've heard this before. In statistics, you probably heard it in maybe one or two other classes. I'm not gonna spend a lot of time on it. There are 4 scales of measurement: nominal, ordinal, interval, and ratio. Which of the 4 scales provides the least amount of information?
Nominal,
Nominal. Which provides the greatest amount of information?
ratio.
Ratio. And in fact, in order, nominal is least informative, then ordinal, then interval, and then ratio. In a nominal scale of measurement is the number that you have a good number in the traditional sense. Now, what do I mean by that? Well, if you took statistics, you should have an idea. Let's say that, here's an example of a nominal variable. Gender. And I could assign a number to the gender. I could give everybody that's female, I assign a number of 1. Everybody that's a male, I assign a number of 2. Those are numbers, aren't they? But do they reflect anything that we typically think of when we use numbers? No, all they're reflecting is that all females get a 1 and all males get a 2. I said it that way because I figured too many females would be offended if I gave males a 1 and females a 2. And there's more females in here than there are males, so I'm gonna hedge my bets and piss off the fewest people. So that's why I say it's not a number in the traditional sense. It's just used to categorize things. Think about breed of dogs. Labradors, German Shepherds, Collies, Setters, any other breed of dogs, and I assign numbers to the different breeds. That would be a nominal scale of measurement. Only thing I need to do is every member of a given breed is the same number. Okay, now let's move up to ordinal scales. Here you have all the characteristics of a nominal scale, which isn't much. But in addition to that, you have what component of measurement? Order or rank. Using the ordinal scale, you can determine more of or less, more than or less than. An example they use is, or one of the examples they use, drink sizes at a fast food restaurant. Small, medium, large, extra large, super size, or whatever the hell they have. Or in a race. Think about that one for a minute. You're in a 100-meter dash. Miranda finishes first. Caleb finishes third. Dominique finishes 5th. That tells me that Miranda ran it faster than the other 2. It doesn't tell me how much faster she ran it. Well, that's the problem with with ordinal scales. You can't determine the amount of difference between the numbers in the scale, or the intervals between the numbers. And that's where we get into interval measurement because there you do know that the intervals between the numbers are equal. Think about that for a minute. If I'm measuring temperature on the Fahrenheit scale, is it fair to say that the difference between 30 degrees and 40 degrees is the same difference in temperature between 60 degrees and 70 degrees? It's a 10-degree interval in each case, and those intervals would be considered to be equal. Okay, now let's take that same scale. Is it fair to say on a Fahrenheit scale that 80 degrees is twice as hot as 40 degrees? Wrong, for those of you who are nodding your heads, yes. You can't do that with temperature. Because in order to make ratio statements, to be able to say that 80 degrees is twice as hot as 40 degrees, you've got to have an absolute zero on your scale of measurement. You've got to have a point that indicates the absence of heat. Now, we do have a point of zero on a temperature measurement. But on the Fahrenheit scale, does zero temperature indicate an absence of heat? No, it doesn't. Feels pretty damn cold when it's zero, but it's not an absence of heat. Same thing goes for Celsius or centigrade scale. It's got a 0 point. What's the 0 point on Celsius scale indicate?
Freezing of water.
The freezing, that point at which water freezes. So it's not an absolute zero. Is there a temperature scale that does have an absolute zero? Kelvin. And so if you're using a Kelvin scale, you could use ratio. That would be a ratio scale. The difference between ratio and interval is that ratio scale has a true 0 point, interval does not. But the intervals are the same on both scales. I mean, the intervals on the scale, if it's interval or ratio, they have equal intervals. Now here's a question I'm going to ask you, since you're all psychology majors. Let's consider, I'm going to give you a variable and you tell me what scale of measurement this is. IQ scores. Okay, I've got one saying ordinal. Do I hear any other possible answers? Does that mean everybody thinks it's ordinal, or does that mean a few people think it's ordinal, the other people just aren't going to give me an answer? Or they're not sure what it is? Is it interval? Is it ratio? Are there ones we can eliminate for sure?
Yes. Ratio.
We could probably eliminate ratio because
There's no absence.
is there a total absence of intelligence? Sometimes I wonder, but probably not. If it's an animate object, well, maybe I should even, well, let's just say this. In most cases in which we're talking about measuring intelligence, we're not talking about a situation where you're going to have a total absence of it. Okay, so we can rule out ratio. We can rule out nominal because it does tell us more than just categorizing people into different groups. So now we've got our choice. It can be either ordinal or interval. And here's where controversy comes into play. If it's interval, if you're gonna say it's interval, then you're making the assumption that there are equal intervals between IQ scores. Is the difference between an IQ of 70 and an IQ of 80 the same as the difference between an IQ of 90 and an IQ of 100? Or break it down to 1-point differences. 79 and 80, is that the same difference as 80 to 81? I would say it's not. Some people would claim that it is. And in fact, in the world of research, often what's done is what I think is probably not particularly appropriate, and that is they calculate statistics on the assumption that it is interval data, when I would argue that it's probably just ordinal. And because of the difference, or if you remember again from statistics, we talked about measures of central tendency, for example, that are appropriate for ratio, interval, nominal, and ordinal data. And depending on your scale of measurement, different ones are appropriate and others are inappropriate. Okay, know the basic scales of measurement, be able to recognize examples, be able to give an example, be able to tell me how they differ from each other. Okay, next topic. Modalities of measurement. Here, the book just gives you a general overview of different types of measures that you might include, that you might want to measure. And it basically breaks it out into 3 different types. Self-report measures, physiological measures, and behavioral measures. Know what each refers to and be able to give examples of each. A self-report measure is exactly what it says it is. You ask people and they tell you. They give you a report of where they are on that particular measure. For example, it says, one option for measure or operationalizing fear of flying is to ask each participant to describe or to quantify her own fear. One might be, are you afraid to fly? My response would be, you mean in an airplane? Or you mean just flying on the own? You're probably beginning to deduce that I don't make a very good participant in psychological studies. So I'd be giving people grief. But you might have asked them to rate how afraid are they of flying? On a scale of 1 to 10, with 10 being the greatest, how, where would you put yourself on that 10-point measure? Or you might give them some type of questionnaire and ask them about, that would measure their fear of flying. Nice thing about self-reports is it's a pretty direct way to assess something. I mean, you would think that people would know about themselves and how they feel, and if they're afraid of flying, they could accurately tell you that. But is that always the case when you use self-reports? Do people often give you honest answers? I mean, do they always give you honest answers? Or maybe they distort their answers so it will appear to be even more socially acceptable. If I'm asking you how often you're engaged in aggressive behavior, and I asked Caleb, how often do you beat up your girlfriend?
Well, I don't have a girlfriend, so.
Oh, you don't have a girlfriend? Well, and then a hypothetical girlfriend. I mean, just thinking about the question.
I wouldn't.
But I mean, the point being, even if you did, would you want to say, well, usually about every hour on the hour? Would you want to tell me that? Whether she needs it or not?
May not hit, I may shake her a little bit.
Oh. Or if it's a question is, if you're conducting sex research, and you want to know about people's sexual behavior, do you think they're always going to tell you the absolute truth about that?
No.
I mean, and it's good, doesn't have to be anything like, it could be even something less sensitive that you'll get distorted answers for. I know it shocks you, but people don't always tell the absolute truth. Abby, you didn't know that, did you?
I didn't.
And also responses can be influenced by how you word the questions, or how the items are worded on the questionnaire. So there are good things and bad things about self-reports. Physiological measures. What would be an example of a physiological measure?
MRI. An MRI.
MRI? Okay. What would be another example? Heart rate? Blood pressure? Cortisol levels?